Okay, so this is the part 2 of hydrostatic force on plane surface. So na-discuss na natin yung derivation ng formulas. So we will now proceed dito sa example. Okay. So actually gusto kong baguhin pala muna um, yung given dito. So ang gawin muna natin yung mas simple muna, no? So ilagay muna natin dito yung liquid surface natin. Okay. So doon lang sa ibabaw ng gate. So disregard muna natin itong nasa taas. Okay. But anyway, yung sa given natin, so 5 feet wide daw yung gate. So perpendicular dito sa screen natin. Okay. So 5 feet wide. Then nandito yung hinge natin sa point B. And nakasandal siya dun sa point A sa wall. So unang hinahanap is yung hydrostatic force uh, sa gate due to seawater pressure. Then hindi ko na siguro tutuloy dito sa B and C, pero kukunin natin is yung i-determine natin muna yung location nung force P. So ganito muna yung kino-consider natin, no? So itong portion na to lang. So i-assume natin na dito sa ibabaw is itong part na to is ano lang, air lang, air for the meantime. Okay? So paano natin isa-solve? So, again, ano yung formula? So, formula para sa force natin is gamma h bar, then yung ating area. Then, para sa location nung centroid natin, so yung y, location nung center of pressure, ycp is yung moment of inertia about the liquid surface, is over area y bar. Pero yung distance e from yung location of force from the centroid ng area is equal to moment of inertia about the center of gravity, ICG over area y bar. So yun na-derive natin nung previous. Okay? So pinagkaiba lang pag YCP is from the liquid surface yung moment of inertia, then ICG kapag from yung distance from the centroid, yung distance E. Okay. So, una, yung force F. So, again, assuming na dito lang tayo sa liquid surface. Okay. So, yung force F is equal to 64 pound force per cubic foot multiplied by, so yan yung unit weight, gamma. H bar natin is, so kung ito lang yung liquid surface natin, so kalahati. So, that is 3 feet. Then, area natin is pwede naman tayo mag-Pythagorean theorem. So, yung length ng gate natin is the square root of 6 squared plus 8 squared. Pero kung familiar naman tayo dun sa right triangle naman to, no? So, sa 3, 4, 5 is yung common. Okay. So, parang ito yung 3. So, 6 over 2 is 3. 8 over 2 is 4. Then, this will be 10 over 2. Para maging 5. So, 3, 4, 5. Then, 6, 8, 10. So, yung length natin is 10 meters. Okay. So, yung area natin is 10 feet pala. Sorry. This is 10 feet. 10 feet by 5 feet wide. So, yung force F is equal to, so we have 64 times 3 times 10 times 5 is 50. So, meron tayong 9,600 pound force. Okay. So, paano natin nilolocate yung ating yung location ng force natin? So, apply muna natin tong gamitin muna natin yung YCP siguro, no? So since ito na yung liquid surface, so yung YCP is manggagaling dito sa point A. Okay. So kung ito yung location ng force F, move ko pa siguro. Okay. So let's say natin yung location ng force F natin. Then yung distance natin from liquid surface is yung ating YCP, center of pressure. So that is again from the liquid surface. Okay, so using yung formula, YCP is equal to IS over area Y bar. So kung hindi natin kabisado yung may formula naman tayo dun eh. Okay. So tingnan ko lang dito sa wala pa pala ako nandito. So for a rectangle, okay. So ito galing sa kinuha ko lang naman dito, sinersyo lang din naman sa internet. Okay. So kung meron tayong rectangle, medyo mali yata yung picture. Okay. Okay, so from the centroid, about x-axis, so that is B, so yung B is yung width, okay. Then yung D is yung depth. So about x-axis, so that is yung width times depth cube, so that's cube over 12. Pero if about sa base nito, rectangle natin, okay, about CD, then this is BD cube pa rin, pero over 3. Okay. So balik tayo dito. So again, yung moment of inertia, ang gamit kasi natin is yung IS about the surface. So since this is base nung gate natin na rectangular, so that is B natin is 5 yung width. Okay. So yung axis kasi natin is perpendicular dito sa screen. So yung B natin is yung dimension ng rectangle na parallel doon sa ating axis. Okay. Then yung perpendicular dimension, which is yung 10, yun yung magiging depth. Or minsan BD cube over 12 or minsan BH cube over 12. Okay, so then this is 10 cube. Okay. Over 12 if centroid. Okay. So medyo malabo nga pala yun na doon sa picture kanina. So ulit lakayan ko lang, no. So let's say this is yung ating centroid na X. Let's say XCG, center of gravity. Then yung moment of inertia about the center of gravity is, let's say this is B. Sabihin na natin H, yung height. So that is BH cube over 12. So again, yung B is yung parallel dun sa axis kung saan tayo kumukuha ng moment of inertia. Okay. Then, if yung axis of yung moment of inertia natin is about the base, so let's say this is X. Okay. So, yung moment of inertia about x-axis is BH cube over 3. So, paano nangyari yun? So, diba, by transfer formula, so solving for Ix, kung ang alam lang natin is yung CG. So, that is BH cube over 12 plus yung area natin times yung distance kung saan natin siya ita-transfer, then squared. So yung area natin is B times H multiplied by, so yung distance natin na to, ita-transfer natin yung moment of inertia about the center of gravity papunta dito sa my base. So that is H over 2. Then squared. Okay, sa baba ko ng konti. So simplify natin. So we have BH cube over 12 plus BH cube then. H times H squared over 4. So 2 squared is 4. Okay. So kung gagawin natin itong 12 din, so multiply natin ng 3 sa taas and 3 sa baba. Or multiply natin ng 3 over 3. Okay. Then this is equal to BH cube over 12 plus 3 BH cube over 12. So pwede natin combine to. Then yung Ix natin about moment of inertia about the base will be equal to BH cube times 3 plus BH cube. Then we have 4 BH cube over 12 or BH cube over 3. Okay? So 4 over 4, 12 over 4 is 3. So yun na nga yung ating formula. So pwede natin gamitin na dito. BH cube over 3 times area is 5 by 10. So lahat ng units natin are in feet. Okay. Then y bar natin. So again, yung y bar is inclined along the plane. So kalahati yung y bar natin from hanggang centroid. Then that is 5 feet. Okay. Then pwede natin cancel to. 5, 5, magiging squared. Cancel na natin yan. Okay. Then we will have so meron tayong 10 squared over 15. Tama? 10 squared over 15. So we have 20 over 3 or so this is feet. Okay, so ano nga bang units natin para lang di tayo malito? So meron tayong feet yung 5, then this is feet. So squared na lang or feet cube yung una over yung 3 natin is wala siyang unit. Okay. Then yung 5 and 10 natin para sa feet. Yung para sa area, dimension. Ito yun. Then yung last is yung distance natin. Ito. Yung y bar. So that is feet then. So feet cube, cubic foot, then cubic foot. And so in terms of feet, yung distance natin. Okay, so kung isi-simplify kasi natin to, this is also equal to 2/3 ng 10 feet. Okay? So 2/3. So bakit kaya 2/3 yung nakuha natin? So kung i-drawing kasi natin yung pressure diagram. Okay? So yung pressure diagram. So since ito, consider muna natin air tong part na to. So pressure natin dito is 0. Then as we go deeper, lumalaki yung pressure diagram. Okay? So from 0 pressure to sa may surface, then yung maximum pressure natin dito sa point B. Okay. So mata natin yung pressure diagram natin is triangular. So kapag triangular yung load, okay, I'm not sure kung nadidinig yung aso. So kapag triangular yung load, then yung location nung resultant force na yon is, so alam natin to, no, sa mechanics. So this is 1/3 nung length. Then yung kabila, of course, is 2/3 ng length. 2/3 ng length. So that's 2/3 ng length natin na 10 meters. 10 feet. Meters ako ng meters. Okay? So yan, no? So yung example natin, if yung liquid surface natin is nasa ibabaw nung gate. Okay? So, kung gagamitin pala natin yung itong formula na to, yung distance E. Okay, so yung distance E is yung distance from, kung ito yung center of, andito yung center of gravity natin, papunta dun sa may force, so that's yung distance E. Okay, so try lang natin. Yung distance E is equal to moment of inertia about the center of gravity, BH cube over 12, yung ito nga. Okay. So yung B natin is yung 5 feet by H natin will be yung 10 feet, then cube over 12. Then multiplied by area is 5 by 10 feet. Then yung Y bar natin, okay, so hanggang doon sa may centroid, which is kalahati ng 10, so that's 5 feet pa rin. Okay. So cancel yung 5, cancel yung 5, 10. Oops, hindi yung 10, magiging squared lang to. So maka-cancel na to. Okay. Then solve natin sa calculator. So we have 10 squared over 12 times 5. Tama? So we have 5 over 3. Distance C is 5 over 3. So, kung kalahati ito, this is 5. Then, nakuha natin ito na 1/3 nung length. Okay, so tama, no? So, this is 1/3 nung length. Then, distance E from that figure is yung 5 feet, which is yung from center of gravity papunta doon sa point B. Ima-minus natin ngayon itong 1/3 nung 10. Minus 10 over 3. Okay, so 5 minus 10 over 3. Okay, so still that is 5/3. Okay, so regardless na kung ano yung gamitin natin, so we can locate pa rin yung total hydrostatic force. Okay. So, paano naman natin kukunin so without using siguro sa next topic na lang para mas ma-appreciate natin. Okay, so, ito yung ating solution. So, ibabalik natin dun sa original problem. Okay, so, i-recall lang natin to, no? Yung force nitong triangular load natin, ng pressure diagram. Triangular load is 9,600 pound force. Okay, so save lang natin to dito. Okay. So, delete muna natin yung okay, so ngayon solve natin yung totoong problem. So, ayusin ko na to. Dami. Okay. So, ang hinahanap ngayon is yung force on the gauge due to sea water pressure. So, solving for force F. So, ito pa rin yung formula natin. So, yung H bar natin ngayon will be from, ito na yung liquid surface natin sa taas, papunta dun sa may centroid. So, somewhere dito. So, this is kalahati, of course, to ng 6. So, this is 3, this is 3. Then, therefore, yung h bar natin will be, so 15 minus ng 3 is 12. Okay. So, 64 pa rin pound force per cubic foot multiplied by h bar. So, h bar natin will be 12 feet. Then, area natin is 5 by 10 meters pa rin to. So, we have 50. Sulat ko na lang siguro. 5 feet by 10 feet. Okay. So, gamma, h bar, then yung area. So, yung force natin is equal to 64 times 12 times 10 by 5 is 50. Okay, so we have 38,400 pound force. Okay. So, feet, so cubic feet over cubic feet. So, we have pound force. So, next is yung horizontal force P. So, meron tayong reaction dito. Okay. So, ito yung force P. Pero before natin makuha yung force P, so kailangan ma-locate muna natin yung application nitong, yung force F natin. Okay. Na 38,400 pound force. So, kailangan makuha muna natin yung distance niya from point B. Okay. Mula dito. So, kailangan muna natin makuha itong distance. Let's say distance X. So, para makuha natin yan, so pwede natin kunin yung distance E. Okay. So, yung distance E, kailangan natin yung Y bar. So, yung Y bar natin is yung distance along the plane. Okay. Along the plane or within the plane ng gate. So, from center of gravity, papunta dun sa may liquid surface. Okay. So, of course, imaginary na lang yung liquid surface natin dito. So, although wala naman yan. Okay. So, yun yung ating Y bar. Y bar or YCG. Okay. Okay. So, paano natin makuha yun? So, pwedeng mag-ratio and proportion na lang. So, meron tayong triangle dito. So, this is 6, 8, then this is 10. Okay. So, 6 feet over yung hypotenuse ng triangle natin dito is 10. So, that is equal to yung vertical height. So, vertical height natin is 15. 15 over hypotenuse natin is yung ating so, Y bar pala hanggang center of gravity lang. So, parang ito yung pangalawang triangle natin pala. Ito. Yan. So, yan yung pangalawang triangle natin. So, this will be 12 lang. Okay. So, yung Y bar natin, H bar natin is 12 over, paano natin makuha to? So, yan yung ating Y bar. Okay. So, vertical height is 12. Ng malaking triangle. Vertical height ng maliit na triangle natin is 6. Okay. So, solving for Y bar. Okay. So, itataas natin yung doon. Bababa natin dito yung 6. Lagyan natin yung 6 dito. Taas natin to dito. Lagyan natin dito yung 10. So, 12 over 6 is 2. Times 10 is 20. Okay. So, pwede naman tayo mag-calculator. Pero, yan. Diretso na lang natin. So, we have Y bar na 20 feet. So, solving for distance E. So, moment of inertia about the center of gravity ng gate. So, BH cube over 12. So yung B natin, again, parallel dun sa axis. So yung axis na kino-consider natin ulit is perpendicular dito sa monitor natin, dito sa screen. So yung B is parallel dyan sa axis na to, which is yung 5 feet by H natin is 10 feet cube over 12 multiplied by area 5 feet by 10 feet. Okay. Then yung ating y bar na 20 feet. So yung distance E is equal to 5 times 10 cube over 12 times 5 times 10 times 20. Okay, so we have 5 over 12. Okay. So this is foot. So yan yung distance E. So therefore yung distance X natin is, so kalahati nung 10 meters na length ng gate is 5 feet. Okay. Minus natin yung distance E. Nandito yung distance E. Minus 5 over 12 feet. Then distance X is, so 5 minus answer. So we have 4.5833. Okay. Okay, so this is our distance X. So we can now solve for the value of P by summing up moments about point B. So pwede nating i-take yung, this should be equal to 0. Pwede nating i-take yung counterclockwise to be positive para unahin na natin yung moment ng P. Okay, so force P times ng moment arm natin. So perpendicular distance. So that is 6 feet. Minus ng force F. Then yung distance X. And this is equal to 0. So force P is equal to, so transpose na natin yung sa kabila. Yung nakuha nating force F is 38,400 pound force multiplied by yung X natin is 4.5833 feet. Then divide natin ng 6 feet. Okay, so ibababa naman natin yun doon sa kabila. Okay, so solve natin yung value ng P. So meron tayong 38,400 times 4.5833 divided by 6. So yung force P is 29,333 pound force. Okay, so cancel lang naman yung feet and feet. Okay, so that is force P for letter B. Okay, so okay na tayo dito. Okay na tayo doon. So last is yung reactions at hinge B. So ang hinahanap is reactions. So meaning more than one. So ang hinahanap natin is yung reactions sa B along X and RBY. Okay. So may mga forces na naman tayo. So summation lang ng mga forces along x and y. So, makukuha na natin yung mga reactions. Okay, so, yung force F, kailangan natin kunin yung components niya, no? Along x and y. But first, okay. So, balikan lang natin ng konti yung mechanics. Okay, so nandito yung ating force. Okay. So, let's say meron tayong angle theta dito. So, kapag nilagay natin siya dito sa portion na to, then this is also angle theta. Then, this will be 90 minus theta. Then, itong kabila is also equal to angle theta. Okay. So, bakit ko pinakita yan? Kasi, kuha tayo ng triangle dito. Yung mga this is parang 3, 4, 5 na triangle. 8, 6, 10. So, equivalent siya or similar siya sa 3, 4, 5. Okay? So, nandito yung angle theta. Okay, so kung ito yung angle theta, so kung drawing tayo dito ng triangle din. Okay, so nandito rin yung angle theta. Ang opposite ng angle theta is 3. Then ang opposite natin, ito na yung opposite, ito yung magiging 3. Ito ngayon yung 4. Then nandito yung 5. Okay. And then, sine of theta based sa mga triangles na yun na 3, 4, 5 is equal to 3 over 5, opposite over hypotenuse. So, instead na sine theta, ang gagamitin natin is yung 3 over 5. Kasi hindi naman natin pa alam yung value ng angle theta. Okay, so, meron tayong component dito ng hydrostatic force. So, let's say this is Fx. This is Fy. Okay. Then, yung Fx will be equal to, iba yung parang hypotenuse natin dito sa triangle na to is yung F. Then, sine theta dapat. But instead of sine theta, Fx is equal to, sine theta is 3 over 5. So, hindi naman nakakalito yan dahil kung papunta ka rito, then parallel na dimension sa kanya is yung 3. Then, over the hypotenuse. Okay, so, if we sum up forces along x, okay, then we will have, this should be equal to 0 dahil equilibrium pa rin tayo. Then, ang mga forces natin, so mag-assume tayo nung direction. So, pababa yung force natin. So, ito lang naman ang kukontra dyan. And this is yung RBY. Then, most likely, papunta dito yung RBX. So, pag nag-negative naman yan, so sabihin baliktad yung assumption natin. Okay, so we will have RBX, then plus natin yung Fx, kasi nandito yung Fx natin, minus P is equal to 0. So, solving for RBX, so transpose natin yung P, magiging positive. So, 29,333 pound force. Pag transpose natin yan, magne-negative. Minus, so yung Fx natin is F times 3 over 5. Or 3 over 5 ng yung F natin, so yun natin sa taas, 38,400 pound force. Then we can now solve for the value of RBX. So isarado ko na lang sa 29,333. Then minus ng 3 over 5, okay, of 38,400. Okay. So, tama ba? 29,333 minus 3 over 5 and 38,400. Okay. So, we have 6,293 pound force. Okay. Then, next, summation of forces along y. This also should be equal to 0. So, ang meron lang tayo is yung RBY, then yung vertical component ng force F natin. So, yung Fy. So, minus Fy is 0. Then, RBY is equal to, magiging positive na yun doon. Okay, so ngayon, pababa tayo. Okay. So, ang component natin is 4 over the hypotenuse. So, yung sin theta natin is 4 over 5. 4 over 5 of F. So, yung Fy is, where yung F again is 38,400 pound force. Which will be equal to 4 over 5 is 0.8 times 38,400. So we have 30,720 pound force. Okay. So nakompleto na natin yung mga required, yung mga pinapahanap. Okay, so simple lang dito, no, dahil number 1 is wala tayong pressure sa ibabaw ng liquid surface. Then homogeneous lang yung ating liquid. So paano naman kung ganitong case? Okay. So yung 5 feet ng seawater, papalitan natin ng 5 feet ng liquid. So any liquid with specific gravity na 0.85. Okay. So paano naman yung magiging solution natin dito? Ang gagawin lang natin is to convert yung i-convert natin yung liquid sa taas in terms of height nitong kung ano man yung nandito na nagsasubmerge doon sa gate natin. So in terms of seawater din. Okay. So paano natin gagawin? So to convert yung pressure, yung height, di ba dapat, no, yung height ng isang liquid to height of another liquid. So ulitin ko lang, yung concept natin doon is they should have the same pressure. Okay, so paano ba natin kinukuha yung pressure? Pressure is gamma H. So let's say gamma 1 H1 should be equal to gamma 2 H2. So if this is gusto natin i-convert dun sa height ng seawater, equivalent height ng seawater, okay, yung unit weight natin gamma 2 is unit weight ng liquid A, then yung height ng liquid A, so i-convert natin siya sa height ng seawater. So H ng seawater is equal to, so yung standard na unit weight ng water natin is 62.4 pound force per cubic foot. Okay, so we have 0.85 ng unit weight ng water, standard 62.4 pound force per cubic feet, times nung height nung oil, nung liquid A, which is 5 feet. Okay, so i-divide lang natin ng ito, unit weight ng seawater natin at 64 pound force per cubic feet. So maka-cancel lang naman yung pound force and cubic feet. So may iwan is yung height ng seawater. Okay, so we have 0.85 85 times 62.4, then times 5 over 64 pound force per cubic foot. Okay. So we have 4.14375 feet. So, kung solve na lang natin, so hindi na natin didiretso dito sa ano, no? So, same problem, pero hindi na natin kukunin yung force P and yung reactions natin sa point B. So, same procedure lang naman. Ang importante is makuha natin or ma-locate natin yung center of pressure natin. Okay. Yung location nitong total hydrostatic force F. Okay. So, ngayon, kinonvert na natin tong liquid A sa equivalent height niya ng seawater. So, assuming na ito na yung height natin ng yung bagong height. Okay. Okay. So, yung H bar natin ngayon will be okay, so hanggang dito na lang. So, sa previous problem, 12 feet. So, ngayon, ito kasi ngayon is, hindi na siya 5. So, yung hanggang dito lang is, so, convert natin siya. So, yung bagong height natin is 4.14375 feet. Then, yung H bar natin will be equal to, so, minus natin yung 3 dito. Okay. So, by the way, this is, so, kung hanggang dito lang, so that is 14.14375. Kasi 10 feet to eh. Plus 4. Okay, so 14.14375. Then yung H bar natin, so i-minus natin 3 meters dito. So this is 11.14375 feet. Okay. So solve natin yung hydrostatic force F is 64. So lahat ngayon yan is-assume na natin na 64 pound force per cubic foot or parang seawater na lang lahat kasi nga kinonvert na natin tong liquid A. So 64 pound force per cubic foot. So that's gamma. H bar natin is 11.14375 H bar. Then yung area natin is 5 feet by 10 feet pa rin. Okay, then yung force is equal to, okay, so we have 64 times 11.14375 times 50 yung area. So we have here 35,660 pound force. So maka-cancel na kasi yung mga feet, yung mga lengths natin. Okay. So ngayon, ilolocate natin yung total hydrostatic force, yung resultant force natin. So definitely that will be still below pa rin siya ng center of gravity. Okay? So using the formula, distance E, so yun na lang yung kunin natin. Itong distance na to. From the centroid, papunta dun sa center of pressure natin. So, yung distance E is equal to, again, that's moment of inertia about the center of gravity over area y bar. Okay, so ano ngayon yung y bar natin? So, kung itutuloy natin to dito, papunta dyan, okay? Then, meron tayong triangle. So, makabuo pa rin tayo ng triangle dito. Okay. So, same yan, similar triangle siya nung nandito sa baba. Okay. So, ang hinahanap natin is itong hypotenuse from, or yung y bar natin from liquid surface. So, doon sa yung sa kinonvert natin na height. So, hindi siya doon sa original liquid natin, which is liquid A. So, kailangan homogeneous yung liquid natin. So, since kinonvert na natin to, so we can assume na homogeneous na liquid natin up to this point. Okay, so, ito lang yung equivalent niya. Okay. So, from this point, pababa doon, so let's say that is yung ating y bar, hypotenuse, over, let's say, itong height. Height natin na to is, again, that is yung 11.14375 feet. So, that should be equal to, yung hypotenuse natin dito is 10 over yung height. So, hypotenuse over height kasi, over 6. Then we can solve for the value of y bar. Okay. So, 11.14375 times 10 divided by 6. So, meron tayong, oops, nangyari. So, we have 18.5729. Okay. So, ICG is BH cube over 12, center of gravity. So, yung B natin is 5 feet pa rin. H is 10 feet ng gate, length ng gate, cube over 12, times area is 5 by 10. Pagsamay ko na unit na nila, square foot, times y bar natin na 18.5729 feet. Okay, so yung distance E is equal to, okay, so simplify na natin, alisin ko na yung 5, alisin ko na yung isang 10, magiging squared na lang to. So we have 10 squared over 12 times 18.5729. Okay. So, nakuha natin is 0.44868. So, compare natin doon sa taas. Yung kanina nakuha nating distance E is 5 over 12. 5 over 12 is 0.41667. So, lumaki. Okay. So, lumaki yung natin. So, kung titingnan natin, kapag pala lumiit yung depth ng liquid above nung surface, so yung distance E naman natin is lumalaki. Okay? So, lumalaki naman pala. So, mamaya makita natin kung bakit ganun yung nangyayari. So, bakit lumalabas na inversely proportional yung E dun sa depth ng liquid. Okay. So, meron tayong different approach na dito sa pag-solve natin, no? So, ang ginagawa kasi natin is using this formula, yung distance na E na ICG over area y bar. So, kung makalimutan natin to, ano yung pwede natin gawin? Okay. So, ito-drawing lang natin yung ating pressure diagram. Okay. So, at point A, dahil meron na tayong liquid above, so meron tayong pressure dito. So, i-represent lang natin itong height na to. Then, habang lumalalim tayo, lumalaki yung pressure. So, mas malaki yung height ng pressure diagram natin dyan. Then, that is varying linearly. Okay. From point A to point B. So, pwede natin itong actually hatiin sa dalawa. isang rectangular, isang triangular. So, ang mangyayari niyan dito sa rectangular na pressure diagram natin, yung force natin dito, let's say F1, will be acting do sa may, since uniform yung pressure, that will act do sa may center of gravity. Then, ito naman, since triangular, so yung resultant force natin dyan will be acting somewhere here. Say, that's F2. Then, pag triangular, so yung distance natin is, okay, so yung distance na to is, di ba, L over 3. If this is L, okay. So, yun yung ano natin, yun yung alam natin do sa mechanics. Okay, so, paano natin kukunin tong height na to? And ano itong triangle? Paano natin makuha tong sa triangle? Okay, kumbaga, dinivide natin into components yung ating force. Okay, so, solve natin yung pressure do sa may point A. So, yung pressure sa point A is equal to, yun pa rin, gamma H bar, gamma H, gamma times height, unit weight, 64 pound force over cubic foot, multiplied by depth. So, yung depth natin from point A hanggang doon sa yung bagong liquid surface natin, dahil kinonvert na natin yan. So, that is, this is 4 meters. Okay. Itong portion na to is 4 feet. Then, from here, papunta dito, so yun nga yung 4.14375 feet. Okay. So, gamma H. Yung H natin is 8.14375. Okay. So, makakuha natin ngayon yung multiply natin. 64 times 8.1414375. So, ang pressure natin dyan is 521.2. So, this is feet. Magiging squared. So, pound force per square foot. So, kaya nga pressure. Okay. Then, yung pressure naman sa point B. So, since mas malalim siya, so same unit weight, 64 pound force per cubic foot, multiplied by, so hanggang ilalim, pinakailalim from the new liquid surface natin hanggang sa ilalim sa point B is 14.14375. Okay. So, yung pressure sa point B is equal to 14.14375. So, we have 905.2 pound force per square foot. So, tama? 64 times 14.14375. Okay. So, if this is, ang pressure natin dito is 521.2. So, dito sa portion na to, 521.2. Pero ang total kasi nito is, yung pressure natin dyan is 905.2. So, yung pressure natin dito, yung height na yan is equal to, so, minus lang natin dito yung 521.2. So, 384. Okay. So, isosolve natin ngayon yung mga forces into components. Yung F1 and F2. So, solving for F1. Okay. So, kukunin lang naman natin yung volume nitong pressure diagram. Or, meron kasi tayong pressure dito na nag-a-act. dalawang pressure, isang triangular, varying pressure, meron tayong uniform pressure. So sa uniform pressure, pressure times area lang, di ba? Or parang ito yung pressure, itong height na to, then yung area natin is yung length and yung width. So parang volume nitong pressure diagram. So we have 5 to 1.2, we have pound force per square foot multiplied by no area kung saan siya naka-apply, 5 feet by 10 feet. Okay? So yung force 1, so 5 to 1.2 times 50. So makukuha natin yung 26060 pound force. Okay? Para sa F1. So solving for F2. So since triangular yung pressure natin, yung pressure diagram natin sa F2, okay? So meron tayong 1/2. So triangular load. Okay, so kukunin natin yung volume nito. So since triangular, so meron tayong 1/2 times. So yung height ng triangle natin, which is yung pressure. Okay, so 384 pound force per square foot. Square lang pala to. Okay. Pressure, so this is squared. Okay, up, sorry. That is cube. And this is squared. Okay. So yan yung height ng triangle. And then times ng base or yung area kung saan naka-apply yung pressure. So yung base and yung width natin na 10 feet by 5 feet. So nakabaliktad lang naman dito. Same lang naman yun. Okay, so solve natin. 0.5, 1/2 times 384 times 10 by 5 is 50. Okay, so we have here 9,600 pound force. Okay, then yung total force F is yung sum nitong dalawa. So kapag in-add natin to, so 9,600 plus 26060. Okay, so makakuha natin pa rin yung 35,660 pound force. So same lang nung nakuha natin kanina. Okay? So next is yung distance E. Paano naman natin yung kukunin? So ano tayo, no? Parang kukunin natin yung resultant force nung F1 and F2. So magre-refer na lang yung distance natin from the center of gravity. So parang ibaba ko lang to. Next problem natin. Okay. So parang meron tayong parang yun yung gate. Then meron tayo ditong F1, meron tayo ditong F2. Yun ang hinahanap natin is yung resultant force F, yung total force F natin. So lahat ng distances will be coming from dito na lang sa centroid natin. Okay? So based dito sa figure, so yung force F times distance, ito pa rin yung distance E. Okay? Times distance E should be equal to yung F1, let's say distance x1 plus F2 distance x2. Okay. Pero yung x1 natin, since nasa centroid din yan, ang distance natin, mga distances natin from the centroid, then yung F1 is applied sa centroid, then x natin is 0, so wala na yung F1 natin. Okay. So solving for E, so that is F2, hinakuha natin, 9,600 pound force times distance x2. Ang x2 natin is ito, no? Ayan yung x2. Okay. Pero since triangular yung load, alam natin na ito is 10 over 3. This is 5. Then, L over 3, 10 over 3, 2/3 nung 10 yung kabilang sides. Okay. Pero from the centroid, ito is 5. So, yung distance nung F2 natin is 5 meters. Yung x2 is 5 minus 10 over 3. 5 minus 10 over 3. So, unit natin dito is feet. Then over yung force natin, yung total force na 35,660 pound force. So, cancel lang yung pound force. Okay. So, ang distance is in terms of feet. Okay. So, solve natin. 9,600 times 5 minus 10 over 3. Okay. Then divided by 35,660. Okay. So, nakuha natin is 0.44868 feet. Okay? So, same lang nung sa kanina. Parang mas mahaba itong second solution natin, pero yung ganitong in terms of pressure diagram is mas ma-appreciate natin, no? If, yung katulad dito sa next example natin, na dalawang liquid yung naka-touch or yung nagsasubmerge dun sa isang plane or isang surface natin. So dito, hindi na apply, pwede pa rin naman na i-apply natin yung sabihin natin yung mga formulas natin, pero parang mas madali kung gagawin natin dalawang separate na area na to. Okay, so iba yung solution dito sa part ng nakalubog sa seawater, iba yung solution do sa nakalubog dun sa oil. Pero balik muna tayo dito. Okay. So, sabi nga natin habang pag malalim, okay, yung distance E natin is lumiliit. So, habang bumababaw yung liquid surface, katulad sa nangyari sa pangalawang example natin, lumiliit yung value or lumalaki yung value ng E. Okay. So, kanina dito, no, yung triangular load F2. So, nung sinolve natin siya, makita natin dito na 9,600 pound force na compute natin. So, kung babalikan natin previous, itong F ng triangular load, nung in-assume natin kanina na ang liquid surface natin is hanggang doon sa may ibabaw ng gate. So, ang pressure diagram natin is triangular. Okay. So, yun din yung nakuha natin. So, sabihin pala kung in terms of pressure diagram, yung rate of change ng pressure natin is the same lang kung same liquid yung siya naka-submerge. So, regardless na yung pressure natin dun sa taas. Okay. So, nung nadagdagan tayo ng pressure, so ito pa rin yung triangular na yon. So, ito pa rin yung triangular na yon. Okay. So, ang nangyari lang is dinagdagan natin siya ng parang nagkaroon tayo ng uniform pressure dito, no? So, it's as if sa previous example natin, okay. So, itong F2 is parang pwede mong i-assume na ito yung liquid surface mo. Okay. Pero instead na air yung nasa ibabaw, meron kang constant pressure na naka-apply doon sa may liquid surface. So, ito yung constant pressure na yon. So, kapag constant ang pressure, so doon sa may centroid. So, habang lumalaki yung pressure natin, okay, above nitong dito sa may pinakaibabaw ng gate. So, habang lumalaki yung depth dyan, so anong mangyayari dito sa may pressure diagram natin? So, lalaki din yung pressure. Kumbaga, lalaki yan. So, parang pwedeng siya maging ganito na. So, sobrang laki na yung uniform pressure. Then, ito yung triangular load natin. So, habang lumalaki yung depth. Okay? So, ano nangyayari? Mas malaki yung, let's say, ito yung F1 compared to sa F2. Lumalaki yung F1. So, mas nahihila niya yung resultant papalapit dun kay F1. Kaya lumiliit yung value ng E, eccentricity, habang lumalalim yung pressure or yung kabila, yung ibang, in other perspective. So, kapag lumiliit yung bumababa yung liquid surface natin dito, so yung force F1 natin, yung diagram niya is lumiliit na lumiliit. Okay? So, lumalaki, kumbaga, mas nagli-lean towards F2 na ngayon yung ating resultant. Okay? So, mas lumalaki yung E. Okay. So, isa pa sa sa pwedeng solution dito is kung ayaw mo na mag-convert itong liquid A, ko-convert mo pa yung liquid A doon sa yung liquid A doon sa equivalent niya na height ng seawater. So, pwedeng hindi mo na gawin yon. So, ang mangyayari nga lang yan, so again, itong triangular load is galing dito sa may depth ng liquid from the top of the gate. Okay. So, ito yung triangular load na yan. Pero yung nasa ibabaw niya, so dalawang liquid yan. So, technically, parang ano to? Para tong dalawang, okay. So, let's say, ito yung F due to seawater. Then, ito yung F due to liquid A. Okay. So, pwedeng ganyan. So, kunin mo lang yung pressure ng liquid A. So, yung pressure ng liquid A is equal to 0.85. Then, yung unit weight ng water natin na 62.4. So, hindi ko na ilagay yung mga units. Okay. So, ito yung unit weight ng liquid A times yung depth na 5 feet. Okay. Then, yung pressure ng seawater. So, hanggang dito lang yun sa may point A. So, that is 64 times nung depth na yun. So, ang depth natin dito is 4 feet. That's 4 feet. Okay. So, pag in-add natin yung dalawa na yan, 0.85 times 62.4 times 5. So, meron tayong 265.2. So, that's pound force per square foot. Then, 64 times 4. So, meron tayong 256 pound force per square foot. So, pag in-add mo yung dalawa, yan pa rin yung pressure to sa point A na nakuha natin kanina. So, i-add ko ulit dito yung 265.2. Okay? So, 521.2 pound force per square foot. Okay, so yun pa rin yun. So, yun pa rin yung pressure dun sa A. Okay, so yung pressure sa A is yung summation ng mga pressure na ibinibigay ng mga iba't ibang layers of liquid above nung point A. Okay? So kung meron pa yung pressure, kung pressurized pa yung air, so madadagdagan din to. Okay, so you have different options. Okay, so dito tayo sa third example natin. So gagamitin lang natin dito yung pressure diagram. Okay? So pressure sa point A. So kung i-drawing natin dito, meron tayong pressure sa point A. Let's call this point C na lang siguro. Point C. Then, ito yung ating pressure dun sa point B. Okay, so since mas magaan yung liquid dito sa yung liquid A natin, less dense siya. So yung rate of or yung rate of increase ng pressure habang lumalalim tayo is not as not as large as compared dito sa dito sa seawater natin. So kung ito drawing natin 'yan, okay? So hindi siya ganoon kabilis mag-increase, pero dito mas mabigat yung liquid natin doon. So iba yung magiging slope niyan. Okay? So parang ganoon. Then natin to sa dalawa, triangle and rectangle, ganoon din dito. Meron tayong rectangular and triangular. So meron tayo ditong, let's say, F1. This is F2. Let's say this is F3. This is F4. Okay. So in terms of distances, so this is 3 feet, this is 3 feet, then this is 5 feet. 5 feet din to. Okay. So 5 feet. Okay. So since this is uniform pressure, rectangular, then this is kalahati. 2.5 feet. Then this is 1/3 ng 5 or 5/3 feet. So ito triangular din to. So still this is 5/3 feet. Then this is also 2.5 feet, kalahati. Okay? So kunin lang natin yung pressure sa A, pressure sa C, and B. So yung pressure sa A is unit weight ng liquid A is 0.85, specific gravity ng liquid times specific gravity ng water na 62.4 pound force per cubic foot. Okay? So that's unit weight pa lang to ng unit weight ng A times ng depth. Okay. So this is 15 meters, this is 6, then this is 9. Okay, so 9 feet times 9 feet. Okay. Zero 0.85. Ayaw gumana ng keyboard. 85 times 62.4 times 9. Okay. So we have 477.36 pound force per square foot. Okay, then yung pressure sa point C. Okay. So same lang 0.85. Makakancel naman dito yung magiging square lang to, no? Yung isang feet makakancel. So hindi ko na isulit yung unit, 62.4. Then yung depth natin ngayon dito is 9 plus 3 is 12. Okay, so depth lang yung mababago. So meron tayo ditong 636.48 pound force per square foot. So yung difference nitong dalawa, kunin natin yung difference, minus natin yung 477.36 is 159.12. Okay. Then, yung pressure sa point B. So, dalawa kasi yung liquid, no? Bago tayo makarating dun sa baba. So, summation lang naman yun ng pressure. Okay. Okay. So, summation ng pressure from top, bumaba tayo doon. So, nag-increase nga ang pressure. So, ang pressure natin dito is, actually, ito na. Yung itong 636.48. 636.48. So, yung pressure doon sa liquid surface. Pound force per square foot plus yung another, dahil bumaba tayo, so mag-increase yung ating pressure. So kaya plus. Unit weight is 64 pound force per cubic foot multiplied by depth na 3 feet. Okay, so makuha natin yung pressure. Dito ko nalalagay. Makuha natin yung pressure na so 636.48 plus 64 times 3. So meron tayong 828.48 pound force per square foot. Oops. Okay. Then yung difference itong dalawa, actually parang ito lang yun, no? Sixty-four times 3, so 192 pound force per square foot. Okay. So itong 192 is itong part na to. Ito yung 192. Then ito naman, itong height ng triangle na to, yan yung 159.12. Okay. So ang height natin dito, ito yung tong side na to ng triangle, ng rectangle natin is 477.36. So that's yung pressure sa point A. Then of course this is 477 din. 0.36. So rectangle na nga. So pag inat mo itong dalawa, so yun na nga yung 636.48. Okay, then yung difference ng yung total height natin na to is 828.48. Okay. Then ang difference natin is 192. So itong nasa baba, ito yung pressure sa point C. Okay. So itong part na to, hanggang dito lang, is same nung pressure sa point C, which is 636.48. So ito rin yung 636.48. Okay. So may mga pressure na tayo. So yan yung pressure diagram. So isosolve na lang natin yung value ng F1 hanggang F4. So F1 is yung volume na itong rectangle. So ang height natin dyan is 477.36. So uniform pressure. This is pound force per square foot multiplied by area. So kalahati lang yung area na kino-consider natin, no? So 5 feet, then yung width nitong gate natin is 5 din. So 5 by 5, then square foot. So cancel lang yan. So pound force yung matitira. Okay. 477.36 multiplied by 25. Okay. So we have 11934 pound force. Then F2. Okay. So yung triangle natin, triangular load. So 1/2 dahil triangle nga. So yung height ng triangle natin is 159.12. That's pressure sa pound force per square foot. Okay. Multiplied by area. So yung area na ina-apply niya, ito pa rin, no? Dito pa rin yan. Or 1/2 nung height, length, and width. So yung length natin is 5. Width natin is 5 din. So paras feet, so that's square foot. Okay? So cancel lang to. Then we will have 0.5 times 159.12 times 25. So 1989. 1989 pound force. Okay, next, F3. So, another rectangular. So, yung height natin dito is 636.48. So, same na yung mga units dito, hindi ko na isusulat. Times nung length, 5. Yung width ng gate is 5 feet din. So, we will have 636.48 times 25. So, 15912 pound force. Okay. So, last is F4. Okay. So, triangular load. So, we have 1/2 nung height. Height natin is 192 pound force per square foot yan. Multiplied by area na yun pa rin. 5. Then, yung width natin, perpendicular sa screen is 5 pa rin. So, 5 by 5. So, 0.5 times 192 times 25. So, meron tayong 2,400 pound force. Okay, so kapag in-add natin lahat yan, yung total force F is equal to, so plus, so may 2,400 tayo, 15912 plus 1989 plus 11934. Okay, so we have here 32,300, 235 pound force. Okay, so as compared dun sa unang example na puro seawater, so 38,400, so yung upper part 5 feet, nireplace natin ng mas magaan na liquid. So bumaba 35,660. So mas lumaki pa, lumalim pa yung konti na lang seawater. So mas malaki yung liquid A, so mas gumaan yung liquid above ng gate, so mas lumiit pa yung ating force. So kung ilolocate na natin yung um, hydrostatic, total hydrostatic force. So, sabihin natin somewhere dito, yung force F. Okay. So, magsasum up lang tayo, magsasummation lang tayo ng moments about, pwedeng about point B. Shift lang tayo ng space. Okay. Okay. Or pwede tayo mag-moment about, kasi yung kinukuha natin is E. Okay. Okay. So, pwedeng E, pwede naman distance from B. Siguro, para mas madali, from B na lang. Okay. So, kukunin natin yung distance. Let's say that is X bar. Kasi ang Y bar natin dito sa kabilang side. Okay. So, force F times X bar is equal to yung F1 natin. So, ito naman yung value ng F1. Ang distance natin dyan is from point B tayo, no? From point B. That is 7.5. So, 5 plus 2.5. Okay. So, we have 7.5 feet plus yung force F2 natin, ang distance naman niya is, so meron tayong 5 dito, plus 5 over 3. So, yung 5 foot, tapos ito yung, hanggang dito yung 5 foot natin, from point B. Then, 1/3 ng triangle, 1/3 dito, ang base ng triangle natin is 5 din, so 5 over 3. So, ang unit din natin dyan is feet. Then, plus yung F3, Distance natin from point B is 2.5. Ito, 2.5 yung F3. Then, i-add natin yung F4. Then, ang distance natin is 4. Distance natin is 5/3. So, ang base, again, ang base ng triangle natin dito is 5. So, since triangular, so this is 1/3 ng base or 5/3. Okay. Then, we can now solve for x bar. So, didiretso na natin dito na ito na may mga value. F1 is 11,934. Ang moment arm natin is 7.5. Okay. Then plus, yung F2 natin is 1989 times moment arm natin is yung 5 foot plus 5/3. Okay, then F3 plus F3 natin is 15,912. Moment arm natin is 2.5. Then plus F4 is 2,400. Moment arm natin is 5/3. Then, lahat yan will be over ng total hydrostatic force natin na 32,235. So, ang expect natin value dito dapat hindi lalampas ng 5 kasi ang center of pressure natin is always lower than or below nung center of gravity. Okay. So kapag lumampas to ng 5, alam natin na may mali. Alam natin dapat agad na may mali sa solution. Okay, so 4.546. 4.5461. Okay, so this is feet. Pero yung distance E from the centroid, so 5 minus answer, 0.4538 or 39 kung i-round off na natin. So, compare natin doon. So, gumaan yung liquid na nasa ibabaw. So, kung i-convert kasi natin to sa height in terms of seawater, so mas mababa pa to ngayon. Okay? So, i-compare natin doon sa taas, 0.448. So, sabi nga, habang lumiliit yung pressure natin above nung gate. Okay? So, lumalaki yung ating eccentricity or yung E. Okay? So, stop muna ako dito. Then, for the next video, so we will have another examples. So, last 2 examples. Okay? So, that's it. So, see you next video.